I've recently had need for a small headlight for one of my little projects that you'll see in the next couple weeks. And I searched eBay, and this little guy seemed ideal, so I bought it. I paid 10 bucks for it, direct from China. The listing says it's an M2 Cree USB interface 5000 LM bike headlight. And I was specifically looking for a USB input lamp because for this project I already have an onboard power source, and I didn't want to have a separate power supply built into the light itself. I wanted to run this off of the existing power system, and USB was a pretty easy way to guarantee some level of compatibility. So here's the light, and just comes with a fairly short USB connection. Here you go. And comes with a little head strap if you want to use it for that, although I imagine a USB power supply might be difficult to sort out. In that case, you'd have to somehow strap a USB power brick somewhere on your body and kind of run a cable somewhere. It'd be kind of annoying. And to mount it to the headlamp, or sorry, the head strap, or the handlebars of your bike, comes with a selection of these little rubber bands, I guess you'd call them. And they just kind of clip around, I guess the other way around. Clip around like this. You put them on sort of like that, and then you pull it around and hook it on this clip here, and it just holds it steady. Okay, so I've got it plugged in. I'll turn on the power supply, and I can't figure out what these lights are for. They look like they might be a power level indicator, but I've varied the power supply voltage and I can't get them to do anything but light that bottom one. Anyways, not much to say about the back. This button just is one of those click to vary the power level type things. So here's one click. It's pretty nice. And you can hear a slight buzzing from the power supply. I don't know if you'll be able to hear that, but that's the power supply, not really the light. There's a small buzzing if you hold it right up to the ear or microphone, but nothing serious. Click it again, and I believe that's full power. Yeah. So full power, it's, let's see if I can find my calculator. Here it is. So at full power, it's drawing about let's call it 1.5 amps at 5 volts. So that's 7.5 watts, which is a pretty good amount of power. It's already getting a little warm. Part of the reasons I bought this thing is that the case looks like it would provide a decent amount of heat sinking, but we'll see how that goes. As for the power circuit, so when it's on full power and I turn the voltage up, so I turn it up to 6 volts, the current actually drops. So that tells me that there's actually a little bit of active circuitry going on in here to regulate the voltage going, or sorry, the current going to the LEDs. Lowest power setting is about 0.4 amps. So 0.4 times 5 is obviously 2. So 2 watts. The next setting up is 0.8, so 4 watts. And then there's the full. If you hold down the button, you get a blinking full power mode. Okay, good sign. These are metal screws, and is that Loctite? It might be Loctite. Doesn't feel like Loctite coming out, but okay. Oh, there we go. Yes, that looks pretty good, actually. Surprisingly good. So nice, very nice cable mounting on this thing. There's a strain relief. The end of the cable is actually threaded, and there's a big old nut holding that onto the circuit board. really quite like that. They've done a good job. They've got a capacitor across the power rail. So that's a little disappointing. This coil here, yeah, this coil here isn't supported by anything at all. And it's just free to wobble there on these very, very thin cables. And there's quite a bit of weight way out there. And as you're on your bicycle, going over bumps and vibrating this all to hell, that thing is going to come breaking off eventually, just due to stress. So I'm quite disappointed in that, if I'm honest. I kind of understand why they did that, because a coil this size would have made this board very difficult to produce in kind of this envelope here, because this board is pressed up flat against the rest of this assembly, and I'll take this off in a second. There's really no room for any components on the back, and just looking at this board here, there's really no place, no spare room in which this could go. Oh, center is here. So that's a bit disappointing. I would have liked to have seen them glue that down, so I might do that as a second step. So let's take off, and that's another problem, they haven't glued this down, so it's just finger tight, which is unfortunate. So I'll be gluing that myself later. Alright, let's have a look back here. Okay. So here's the clicker button, just about what you'd expect. And a couple capacitors, a resistor, and the 3 LEDs. Status LEDs. Are they in series? No, those are just a ground connection. I'm really not sure what those are for. Okay, so let's take a look at what these chips are. Could use a little bit of extra light. So the small chip is LEDA 1512. Let's see what that is. Okay, well unfortunately I couldn't find any real information on that chip. Just a bunch of Chinese websites that 404 when you click the PDF link. But it's one of those generic LED driver chips. It looks like a clone of a Cree part, but anyway, that's that chip right here, and it's going to a MOSFET directly, so it's pretty clearly the switch mode driver, and especially because it's right next to this coil and this rectifier here. So this looks like a Schottky rectifier. And this chip over here is completely unlabeled, save for this little dot here indicating pin 1, so I'm afraid that's a dead end right there as well. As for the case, it's a pretty nice, it looks to be machined actually. I can see the tool marks, and it's actually pretty nice. It looks like they maybe extruded the main body and then machined out these recesses for the board and everything else to kind of be pressed into. The screws go into the aluminum. It's tapped, so that's pretty nice. And looking down in there, there's some Loctite in there, so that's excellent. They were thinking through that, but I really am disappointed in this choke here, or coil. Alright, let's take a look at the front. Yep, that's definitely Loctite over there. I'll have to remember to replace that. So the screws in the front are different. And yeah, this is definitely a glass lens. with a little O-ring. The reflectors, is this aluminum? Yep, aluminum reflectors. I gooped down the choke with just some hot glue. Not the most solid thing, but it should help. And I also gooped down the nut holding on the strainer leaf. And on the subject of waterproofing, I was kind of looking at this, and this isn't fully waterproof. So basically there exists a leak path between the glass and the outer surface of this thing here, because the O-ring only really seals between the glass and the retainer here, but there's nothing sealing the glass against the metal case. So don't expect this thing to be fully waterproof, unfortunately. However, a little bit of sealant between this and the case and kind of squish down will solve that problem if you're worried. Should be enough wire. Yeah, so this is an aluminum backed PCB, and not much on there apart from the LEDs. So and that just sits in a recess with that's backed up with a shoulder. So in terms of thermal transfer to the case, it's not bad actually. There's contact with just the edges of this aluminum. I might squeeze a tiny little bit of heatsink compound on there just to help it along. But yes, so I think what is happening here is that there's a constant current drive, which is implemented with this choke, the rectifier, and this little driver chip, and this MOSFET, and the blinking and different power levels are implemented by using PWM on this chip here from, I guess this is a generic lamp, LED lamp chip that's dealing with the button presses. So pretty straightforward. I still don't understand what's up with these LEDs down here, these little status LEDs, but whatever. I don't really mind too much. So yeah, if you're in the market for one of these little 5-volt lamps for your bike or for whatever, I would recommend these, because for your money's worth you're getting a decent amount of machining here and a pretty good electrical design. But if you do end up getting this, I would definitely recommend figuring out a way of tying this choke down, because this is just going to break off. So anyways, thanks for watching. And if you couldn't tell, this video was inspired by Big Clive, bigclive.com. If you're interested in these kinds of teardowns of random products from eBay, head over to his channel, and I've certainly found it useful. And anyways, see you next time.